morning, good afternoon, good evening, wherever you are. Welcome back to another episode of the MRMIA broadcast. You're listening to the Model Risk Managers International Association broadcast, and I'm your host, Marc Leprince. And today we have a special guest from Belgium. You might recognize him from one of our previous podcasts, Bart, and I'll let him introduce himself.
Thanks very much, Marc, for the introduction. So my name is Bart Baesens. I'm a professor of big data and analytics at the Catholic University of Leuven, and I also have an appointment at Southampton Business School in the United Kingdom. So I work on analytics or data science, if you want. I do research on the development of new algorithms, new ways of analyzing data, but also on innovative applications of these algorithms, more specifically in fraud analytics, in credit risk analytics, in marketing analytics, etc. So that's more or less in a nutshell who I am and what I do.
Excellent, excellent. And so to our viewers out there today, the topic we're going to cover is fraud analytics. And we're going to kind of go through a little high level overview into what fraud analytics is, the current practices, the data they're analyzing, as well as what all of that means for model risk. And so the place that I like to begin when I try and learn a new domain of expertise is I ask, what are the big questions that fraud analytics is trying to answer?
That's a very good question to kick off. And actually, the best way to approach this question is by starting from a definition of fraud. And in our earlier work, we defined fraud as an uncommon, imperceptibly concealed, well-considered, time-evolving, and carefully organized crime, which can appear in many different types of forms and shapes. So let's disentangle this definition a bit, and that will also allow us to see what the challenges are. Fraud is uncommon. It doesn't appear a lot. It's a rare event, and basically what you need to do then from an analytical perspective is you need to look for a needle in a haystack, which is very challenging, right? So from an analytical viewpoint, your analytical technique is being flooded with legitimate transactions, with legitimate actions, with legitimate events, but you have to find those few ones that are actually fraudulent, right? So that creates quite a bit of analytical challenges. It's imperceptibly concealed, which means that the fraudsters try to blend in as much as possible, much like a chameleon does in nature, into their surroundings, into their environment. So from a data perspective, this poses quite a bit of challenges because you have to carefully look for those predictors, those features that you have to engineer that allow your analytical technique to differentiate or discriminate between legitimate transactions and fraudulent transactions. Fraud is also, according to the definition that I just stated, is time evolving. That means that fraudsters are continuously on the lookout to outbeat the analytical the analytical models and be smarter than them. That means that your analytical models need to be continuously backtested and monitored such that if new fraud patterns start to appear in your data, such that you can capture those in a very timely way. And last but not least, what we often have seen in settings like tax evasion fraud or money laundering or credit card fraud is that fraud is carefully organized. So this opens up the perspective of social network learning, where you're going to leverage networks of data between merchants and credit card holders and see how fraud, much like a virus, very relevant nowadays, spreads throughout your network of data. These are more or less, in a nutshell, the challenges that I see as being very important in fraud analytics nowadays.
Okay, so just to kind of summarize for myself here, it seems very focused on being able to really differentiate between what's truly fraud versus business as usual transaction. And what makes it unique here is that it is such a rare event compared to the vastness and enormity of non-fraud cases. And then you compound that by the fact that it's changing continuously as the bad actors are evolving. And then finally, with kind of the social engineering and proliferation effect of how, if they find an avenue, they're going to expand and reproduce that kind of effect throughout.
Yes, that's very nicely summarized, right?
Okay.
And one thing that I want to jump into a little bit as well is
Mm-hmm.
that from an analytical perspective, what those analytical techniques usually can do for you is they can label transactions as being suspicious, yes or not. And what's really very important to add on to one of the first points you just made is that there will always be a human decision maker that needs to be involved in the loop to decide whether those suspicious transactions that have been found by your predictive or descriptive analytical techniques, whether they actually turn out to be fraudulent, yes or no. So analytics is good at labeling them, at finding suspicious transactions, but it's up to a human decision maker, sometimes even up to a court decision, to see whether a transaction was actually fraudulent, yes or no.
Mm-hmm. Okay. So let's take this now kind of a step further from uh, the question of what we're trying to analyze into the data now. So when we're performing fraud analytics, what kinds of data are we looking at?
You can look at various types of data, and I will make a rough distinction between structured data and unstructured data. First, we
Okay.
zoom into classical structured data. Structured data could be like the RFM framework, which has been very popularly well used in marketing analytics. R
Mhm.
stands for recency of a transaction, F stands for frequency of a transaction, and M stands for monetary value of a transaction. So these are ways of characterizing transactions. And if you see deviating patterns in any of those structural features, then that could already be an early warning signal that something is going on, that something is suspicious. These are examples of classical features, structured data elements. But more and more, we also see unstructured data being used for fraud detection. And when I say unstructured data, I am, for example, referring to the networks that I already introduced as an answer to your first question. And those could be networks between credit cards, credit card holders, and merchants, because typically in a credit card fraud detection setting, you will see that merchants will process legitimate transactions to cover up their fraudulent activities, but obviously also have quite a number of concentration of fraudulent transactions. So finding those using network analysis is something that we can do nowadays. But there's also imagery, right? Image data, which is becoming very important for fraud detection. Think about drones, for example. Insurance providers are more and more looking at drones as one of as a very interesting way to capture data in their insurance fraud efforts. For example, suppose there was a storm at your place, and all of a sudden, there was damage to your roof. The question is, does the damage originate from the storm, or is the damage inflicted by yourself after the storm because you want a new roof, right? And that's something that you can perfectly capture with drones, because you can send out drones before the storm takes place and take images from the whole scene. And then once the storm has taken place, you just take some ex-post images and you contrast both to see what damage was actually inflicted by the storm and what is what I would call staged damage that was on purpose done by the house owner in order to file a fraudulent claim. So this is another example of image data, unstructured data that can be successfully leveraged for fraud analytics. It obviously comes with a challenge as well, because there we have again the privacy challenge that comes that also should be taken into account, obviously.
Mm-hmm. Okay, so then these are kind of the current data sources being used to look into fraud. Are there any new or emerging data sources that are starting to get looked at to gain an additional edge in determining fraud?
Obviously, as I just said, the biggest set of data sources that that I believe in are these unstructured data sources, the network data sources, the video imagery data sources. But also, I mean, what else you could look at is open data. If you have access to open data, that could also be something that could be of interest. And also macroeconomic data, obviously, because we do see, because of the whole COVID pandemic, we see quite a lot of evolutions going on in the macroeconomic environment. We see that inflation is on the rise. We will also see that, I mean, we might anticipate maybe a few periods of a successive GDP contraction. All of that, although it's on a macroeconomic level, can put pressure on people to commit fraudulent transactions. So also this external data, be it on a more aggregate level, can also have an impact on your fraud analytical models, and should also be factored in as such, I believe.
Okay. So kind of using other factors to look at broader trends and just see if there's we expect a larger volume, let's say, of fraudulent transactions.
Yes.
Not necessarily different ones, but a larger volume. Okay.
Yes.
So now that we have a good understanding of kind of the data that we're looking at to analyze fraud, let's dive into the models and methodologies used to interrogate that data. So when you're performing fraud analytics, let's say with that RFM data you were mentioning, what types of models work well for those versus let's say your network data or unstructured data, such as images?
Well, I'm going to give you a very precise, maybe a somewhat nerdy answer, because I'm going to also cite some techniques, because we're doing research on that on this very moment. So basically, the way you can tackle fraud analytics is twofold, right? So you can tackle it in an unsupervised way. An unsupervised way means that I just give you a set of transactions, like cash transactions or wire transfers, and I ask you to find the deviating ones. Right? That's unsupervised. That means that we're looking for the anomalies. We're looking for the outliers. And there exists a plethora of methods that have been used to tackle this. And right now, for those of you who are a little bit more familiar with analytical techniques, you have techniques like local outlier factor, you have techniques like isolation forests, and you also have techniques like deep learning, like autoencoders, for example. And we're currently wrapping up a benchmarking study, and we find that isolation forests, which are an extension of random forests, but to work in an unsupervised way, we found that those usually are amongst the best for unsupervised anomaly detection. So that's a technique that I can highly recommend to the audience here. Another way that you can tackle fraud analytics is not unsupervised, but supervised learning, which means that you have a historical data set of claims, of observations, of transactions available, and various types of columns. The columns are the predictors, and there's one special type of column, which is a label that has been assigned to those claims, to those observations and transactions, and the label says fraud, yes or no. And then we have a supervised setting, because now that label can be used to steer our learning process. And that means that we can do predictive analytics, and we can resort to any type of predictive analytical technique, like logistic regression, which is very popular, decision trees, or one of my favorites is XGBoost, which stands for extreme gradient boosting. It's my favorite technique if you're into black box, yet high-performing analytical models. XGBoost is always the best. It always comes out as the best analytical technique amongst most of the research projects that we've done. You do pay a price for it. The price you pay for it is that you have a black box model that is very opaque, that is not very transparent, but there exist facilities like Shapley values and partial dependence plots that allow you to open up that black box and shed light into what is happening on the inside of that black box. So that's more or less what I would recommend as the state of the art in fraud analytics with respect to the techniques that are currently being used.
Yeah, and I know that there's been a lot of advancement in AI and machine learning. Has that kind of changed or evolved the landscape of models used here, or the combination of models used to address fraud analytics?
Yeah, I think so. Recent developments in machine learning, for example, deep learning,
Hmm.
which are very complex neural network-alike techniques, allow us to process very complex data and combine it with traditional data, like autoencoders or deep learning neural networks, like convolutional neural networks, which are excelling at analyzing unstructured data. All these type of new deep learning techniques come in really handy to analyze unstructured data and take into account unstructured data like images, maybe like audio data sources, and factor those into your fraud analytical models.
Yeah. Yeah. Very good. Very good. So nice to see that machine learning is making kind of a new foray and evolving the fraud analytics space. So let's kind of transition this more towards model risk in
Mhm.
terms of now that we know the kind of foundations of fraud, we know the data, we understand the methods and approaches now. What does this all mean for model risk?
It means various things for model risk. And let me just zoom into that a bit extensively, if you allow me. The first important impact or origin, let me say, the first important origin of model risk is data risk. It relates to your data not being perfect. And the data risk can be because of data quality, because of missing values, because of inconsistent data definitions, but also, and that's very typical for fraud, that's a typical source of model risk that pertains to fraud, is that if you work in a supervised setting, if you have that target indicator available that tells you which transaction or claim is fraudulent, yes or no, that target indicator is always noisy, right? So it
Mhm.
could be that historically a claim has been labeled or transaction has been labeled as fraudulent, but the one who labeled that one transaction or claim as fraudulent is not 100% certain. And that's typically what you see in fraud analytics, is that the labeling of the target is noisy. Your target is noisy, right? And that's something that your analytical techniques have to be able to cope with in coming up with their analytical models. So that's the data risk is a very important thing. And then we have the algorithmic risk, right? So every algorithm has its own particular biases, right? So you can come up with a very simple logistic regression, which has a linear bias because it separates the fraudsters from the non-fraudsters using a linear decision boundary. But you can also have an XGBoost model, which is very complex, which is highly nonlinear, but it also comes with a risk. And the risk it comes with is that you have a black box model. So the black box risk could be very important in case you want to do fraud prevention, for example, because if you want to do fraud prevention, you want to carefully understand what's under the hood. What are the patterns that the fraudsters are currently using? And
Mhm.
that's a key shortcoming of XGBoost, is that it doesn't provide that white box explanation power that you're after. And then obviously there's a third type of model risk or a third source of risk, and that's putting everything into production, into deployment. And that is also a bit dependent upon the environment that you're going to use. And what's very important there is that it was David Hand, one of my closest friends and a professor who is now retired working at Imperial College, that said, as soon as you put a model in production, an analytical model in production, it's outdated. And it's definitely also, this definitely also applies to fraud, right? Because the data changes, the environment changes, and the one condition that we always assume is that when the data was sampled, the environments, the internal and
Mhm.
external environment will be the same in the future. And that's not necessarily true.
Yeah.
Definitely not in fraud analytics, because as soon as you put a fraud analytical model into production, the fraudsters will try to outsmart it, will try to beat it by coming up with new creative ways of committing their fraudulent transactions. And that's why an important source of risk is also being on the continuous lookout for new fraud patterns and see how fraud is actually time evolving, as I stated also at the start of this interview in my definition.
Mm-hmm. Yeah, I think that's one of the very unique things about fraud analytics, more so than, let's say credit risk, which is often a very
Yeah,
large area of analytics at the bank, where your implementation cycles can take months at a time. And so long as the macroeconomic landscape doesn't change very much,
mm-hmm.
your assumptions remain
Yeah,
valid. But in this case, it's fascinating to me to see just how the volume of data and also the velocity, how fast it's coming at you, changes. So that
yeah,
kind of makes some very unique challenges to this space.
yeah. Also creates quite a bit of interesting research challenges nowadays that we're working
Mhm.
on. So yeah, it's a very fast evolving area, which for us researchers is always very exciting to work in because that's what we love to do.
Yeah. Oh, yeah. I bet it's going to keep you busy for a while.
Yeah.
Um, so then let me kind of bring this to the last question I have here, which is about validation. So now, we have a very fast paced data environment. We have some big heavy hitter models. What are the challenges for folks out there that are trying to validate fraud models? What should they keep an eye out for? Um, and how can they keep pace?
What is very important, I think, is if you want to validate a model, you want to understand it first,
Hmm.
right? So if I ask you, Mark, here's a complex method, not that I underestimate your mathematical capacities, by the way, but if I give you a very complex mathematical model, even if you give it to me, I mean, it is very complex to understand. The reality is very complex. Fraudsters are actually, the frustrating thing, Mark, is that fraudsters are really smart, right? And they're getting smarter by the day because they're constantly on the lookout for the loopholes in your analytical models, in your analytical techniques, right? So what is really very important from a model validation perspective is interpretability, is to complement your analytical technique, the analytical model that you have built and that is high performing, that is very capable of detecting those few fraudsters, those few needles in that haystack, is
Hmm.
to see why are they needles? Why are they fraudsters? Why do we label them as fraudsters? All right, and
Hmm.
that's very important. Is interpretability. It's complementing the analytical technique with various types of explanatory tools. And that's one of the areas that we are also doing research on. That's the interpretability aspect. And we try to use various techniques like, I don't know whether some of the audience may be familiar with Shapley values. That's very
Hmm.
important, a very important way of actually giving interpretability to your models. But what's also very important, I think, from a model validation perspective, is I think the economic validation of your models, right? Because at the end of the day, you want to look at the bottom line impact of your analytical fraud models. You want to see how much profit do they give you. Sometimes if you have a transaction which is a low value transaction of which you think it's maybe fraudulent, you don't want to bother investigating it because it will cost you more to investigate it than the amount of fraud that is potentially committed. So that brings about the economic factor in the validation process, which I think is also very important, and that it's also something that we're doing research on. Because what we've done in one of our most recent research project, we framed fraud analytics and the validation of fraud analytical models from an economic perspective. And we came up with a very nice way of quantifying the economic return of a fraud analytical model and directly embedding the return into the model development and the model validation process. So to summarize my answer to your question, what are the important challenges in a model from a model validation perspective? I think they're twofold. First, the interpretability, especially from a fraud prevention perspective. And secondly, the economic return of your models is also something that should be properly factored in during model development and validation.
Yeah, that's really fascinating, especially that economic piece. It's all inherent to, the businesses we're working with, banks, of course.
Yeah.
Everyone wants to be able to make and save money. But it's very interesting in this case that it's very easy to tie dollars to the analytics that you're doing. That every transaction that you flag as fraud has an associated cost to investigate, and could potentially save the bank X amount of dollars. Or, do we leave it alone and let it pass by and we see whether or not it was fraud on the back end?
Yeah, exactly.
And so I have kind of one last question for
Go
you
ahead.
as it relates to fraud models is, after it's in production, I'm sure that, let's say a fraud model is in production for a handful of months, let's say 2-3 months, and the bank over that period of time will experience certain amounts of actual fraud slip through the cracks. How should folks think about back testing their fraud models?
They should backtest their fraud models by looking at the way those fraud models have been developed from different perspectives. The first one is by looking at the key ingredient of your fraud models, and that's the data. You should look at data stability, right? The data that we have used to build the fraud analytical model, is that very similar or similar enough to the data that we witness nowadays. And there exist various types of diagnostic measures that allow you to quantify that data stability, right? There exist things like the system stability index, like chi-squared measures and so on, that allow you to see, has my data population structurally changed, yes or no? If yes, then that's an early warning signal for your analytical model degrading in performance. And next thing is that you should also look at the analytical technique or the analytical model itself in terms of its discriminatory power, in terms of its lift, in terms of its Gini, to see to what extent it still manages to appropriately discriminate the fraudsters from the non-fraudsters. And if you see that, and that's not something that happens overnight, that's something that is gradually taking place, you will see that the performance gradually decreases. And at some point, you will have to say, look, we have passed a certain threshold and we need to re-estimate our analytical fraud model in order to guarantee that we still have enough performance in terms of Gini or any type of other test statistic to discriminate the fraudsters from the legitimate ones.
Excellent. Yeah, I think being able to figure out whether or not you have a good model is probably still one of the biggest challenges out there for model developers, as well as folks on the model risk side as well. So I'll kind of leave it there to kind of wrap up our introduction into fraud analytics. And so, Bart, do you have any other last thoughts that you'd like to share before I close this out?
No, thank you very much, Mark. As always, pleasure doing this with you. And also to the audience, if you would be interested in any of my work, feel free to reach out. Thank you very much.
Excellent. We'll be sure to link your YouTube pages, and I know you have a number of LinkedIn posts and other pages as well. So we'll make sure to share those with our audience as well. So to those listening, we hope you enjoyed this episode of the MRMIA broadcast, and we hope to see you again soon.
Bye, everyone.